Okay, so solving multi-step equations. We did 3-1, which was one step. We did 3-2, which is two-step. And now we're doing 3-3, which is multi-step, okay? Multi-step means it's going to take you more than two steps to get this variable by itself, okay? So the first thing we'll talk about is, let's just look at example 1. Example 1 says 8x minus 3x minus 10 equals 20. Okay? So I have to look at 8x minus 3x, and hopefully you remember from last year that you always want to look for combining your like terms, and 8x and minus 3x gives you 5x. And we know that Mrs. Z likes everything else to be recopied. And so my first step was to combine like terms, right? And once I combine like terms, it looks like a regular two-step equation, which I then will cancel out my constant and go from there. So cancel out your constant, keep that equation balanced. After you cancel this step out, what is the resulting terms that are left? 5x, 30, and then you divide using the division property of equality, and x is 6. I am going to kind of fly through these because we spent a big chunk of time last year in 7th grade solving equations. Like, I feel like you guys could have solved them in your sleep, right? Okay? So today we're getting to the fun ones with the parentheses and distributing and all that good stuff, okay? So my second step after I combined like terms, it was to add 10 to both sides, and then I divided both sides by 5. You do not have to write that, but that just goes to show you that there were 3 steps. Okay, let's talk about the distributive property. If I have 5 times a plus 4, you know parentheses are to be done first, but when these are not like terms, your only option is to multiply everything in the parentheses by the term on the outside, and that's called distributing. 5a plus 20, right? What if I took that and instead of made it 5 times a plus 4, 5 times a minus 4? What would that change? Yeah, we'll just make it a negative 20, right? Good. Because that is a positive 5, that's a negative 4. There's 2 more to do. What if I make the 5 negative, but still keep the a plus 4? That just means what? Negative 5 times a is negative 5a. What's a negative 5 times a positive 4? Negative 20. Good. It's the only last one I didn't do yet. A negative 5 and a negative 4. So while I'm writing this, I'll give you a minute to catch up. Yes, you absolutely could have a negative a. Negative 5 times a is negative 5a. And now be careful. What is a negative 5 times a negative 4? Positive 20, yes. So this is the trickiest one, and I want you to be careful that when you have a negative times a negative, that's what gives you your positive, okay? Is that too? That's better. Yeah, let's do that. Will says, what if I just have this? What if there is no number in front? Well, there is. It's just a 1. This is also considered, just looking at it, as taking the opposite of this expression. Because we know multiplying by negative 1 just changes the terms. So what's the opposite of a? Negative a. And what's the opposite of negative 6? Positive 6. Good. Now, what would happen if you have something like this? This goes beyond just distributing. It's distributing and then combining, okay? So I want to do this first, which is going to give me 15x minus 10, and then this just kind of comes down for the ride until we need it, right? And we need it now because I have a 15 positive x's and 4 negative x's, and when I combine, that gives me 11 x's minus 10. Is everybody okay with how we got that? Do you remember doing these like crazy last year? We did a lot of these. What if I have negative 2a minus 4a minus 5? Take a minute and try to do that one. So what exactly are we distributing? Not the 2a. We're just distributing the negative. Good so far? When you distributed, you had the opposite of positive 4, the opposite of negative 5. Now I have two like terms, right? And they're both negative, even though that looks like a minus. Negative 2 plus negative 4 is negative 6. And I cannot combine these two because it doesn't have a 5. Okay, so I thought you said the title of the section was solving equations. That was just, simplifying expressions. Well, guess what? You got to be able to do all that and then set it equal. So that's what we're going to talk about next. You ready for this next example then? All right. So example 2 starts out 7x plus 2 times x plus 6 equals 39. And if we just apply the two separate lessons of distribute and combine, then solve, you have all the tools you need to probably already solve this on your own, but we'll do it together for this first one here. So let's put, and if you are already comfortable with what needs to be done first, you don't have to put that box. It's just like a teaching tool that I use to kind of make your eyes go where they need to go first, which means the 7x is hanging out. That 2 is distributed, and 2 times x is 2x. 2 times 6 is 12. Then I have to, so my step 1 was to distribute. Step 2 is going to be to combine like terms, which we'll do now. 9x. Then you need to write everything else down. So right now on my paper I've used 3 lines so far, right? And it took me 3 lines. And what I guess what we can say is this. Your goal is to always get it into be a 2-step equation, right? Because we worked it out to 5x minus 10 equals 20. We worked this one out to 9x plus 12 equals 39. If you can get it into 2-step equation, you're kind of home free, right? Because you should be able to kick it out from there. This, cancel it out. I'm on another line. 9x is equal to 27, sorry. And a whole nother line, and I'm still not done. When I divide both sides by 9, x is equal to 3. 1, 2, 3, 4, 5, 6, 7 lines. I was a little lenient today when I was walking around checking for your 2-step equations, which was basically all of that. I need to see like 5 or 6 lines. I don't want you skipping steps. I explained why. Make sure you show the steps. It lets me get in your head. So all your answers should kind of start to look like we said first hour, like upside down Christmas trees or something, right? Okay? So they start out wide and you get them more narrow each time because you are simplifying. Okay. I'm going to show you one other shortcut. What would you do if you had 3 halves times 3x plus 5 equals negative 24? Well, I don't know about you, but, I don't mind distributing, but distributing a fraction to 2 terms that aren't even going to give me whole numbers doesn't sound like fun. Yeah, I'll get 9 halves, which I could turn into 4.5, and then I'll get 15 halves, but you know what? If you don't want to distribute by 3 halves, then don't. Get rid of it. How can you get rid of something that you don't want there? You cancel it out. And how do you cancel out a 3 halves? What could you multiply it by? The reciprocal. Good. So you're telling me if I multiply this by 2 and a 3, look what that does. It gets the 2's gone, it gets the 3's gone, and what's left over here? Just that. But as of right now, I have an equation that's unbalanced. I can't mess with this side of the scale without doing the same thing to the other. So if I multiply by 2/3 over here, I better multiply this by 2/3 also. Maybe put that 24 over 1 if you need to. I really want you to make sure you work on your cross-canceling so you don't have to worry about reducing. So 3 goes in here once, and in here 8, And don't forget, this is the problem with multiplying with fractions. You may look at that and just say, oh, 8 times 2 is 16, but don't forget it's a negative 8 times 2. And look what I did. I got it back to a two-step equation, which is what I said your goal is, right? And then we undo what's being done to the variable, which is basically order of operations in reverse. So normally we would multiply or divide, but because we're undoing, we're going to do the constants first, which is your addition and subtraction, which leaves you with 3x. Same signs, add and keep. Distributive or the division property of equality. X is equal to negative 7. Understand? I know I flew through it, but I feel like I know I was half of your teacher last year, and Mr. Meeks, I know we really stressed these. So you're going to do page 150, just the odds, which takes it down to 13 problems or so. But I'm looking for good work. Like I may pull your work up and put it on the overhead to see, to let everybody see who's got the neatest paper or something. Leave spaces, space it out good. Okay?